So we want to graph exponential functions still, which we know how to do, and interpret solutions. You've done the interpretation of solutions. You've done rate of change already. You've done it with linear. We've done it with other things as well. This is now just in terms of exponential. So this whole entire topic is not really brand new to you guys, but it's applying it to a new situation of exponentials, which you guys just started learning over the past week or so. Okay? So I can find the average rate of change over a specified interval given a table or graph, which we've done already. And I can find the input or output of a function given the other and its graph and interpret the meaning and context. So this was on your homework assignment last night. We hadn't taught it to you yet, but you guys kind of had an idea of how to do it from previous topics, but we're really going to touch on it today. So again, we're kind of just combining stuff that you've learned throughout the year with exponentials. So let's practice it with linears first. First of all, how do I know these are linear? Why do I know these are linear? Can somebody explain that to me? Yes. If you put them on a graph, so if you make a table and you put them on a graph, it will make a straight line. You are right, Jenny. Don't stop yourself from talking. What's another way you can tell? Somebody else tell me another reason why this is linear? Go ahead, Kelly.
It's in y equals mx plus b form.
Yeah, even though that's an f of x and a g of x, that's still f of x and g of x mean y, so that looks like y equals mx plus b. What is one other way you can tell? Mackenzie? There's no exponents, right? They're 1. The exponent is 1, so it looks like there's none. Very good. So those are 3 kind of different ways you can tell there. So, evaluate the function. This is saying when x equals 3, which is your input, this could have been written as f of 3, right? It could have been said find f of 3 here. That means the same thing. So that means we plug in 3 wherever we see an x. And we solve. So when you input 3, 10 comes out. The next one says there, g of x equals 5x plus 2. G of x equals 2. Is g of x equals 2, that 2 your input or your output, Sarah? Output. So remember, that replaces g of x. You're saying g of x is the same thing as 2, so you can replace the g of x with 2. And then you will solve for x. It's okay to get 0, guys. You guys sometimes have panic attacks when you get 0. 0 is a number. You can write down 0. We divide by 5. And we get x equals 0. All right, does that seem familiar to you guys? Things that we did in Unit 2. We applied those to linears last unit, so now let's apply this to exponentials. Bless you. Bless you. Do we have any questions before we move on? All right, function notation. It's the number of cell phone users and time in years. So we know it's x comma y. So time in years is x. And number of cell phone users is y. So we know that when we go to write up our answer, since there's units on this, we must use those units. You must use those units whenever there are units given. Do not just give me a number. Something I really want to focus on with you guys if you haven't noticed, because you guys are struggling with putting units on things. Okay, Morgan. A says find f of 7. So first tell me, is 7 input or output? So is that x or y? So we know x equals 7. So how could you find the output then if x is 7? What could you do? Look on the graph. And it's going to be an estimate because these are not exact points. But do we look for 7 on the vertical axis or the horizontal axis? Yeah, so you find 7 here, and you follow it up, and follow it over. And what do you think that's about, Morgan? So it looks like it's actually counting by 1,000 each time. So this one here is 12,000. So this would be 13, this would be 14, 15, and then 16. So what is it closer to, 15 or 14? 14,000. So it's a little bit more than 14,000. So after 7 years, there are about, I'm saying about because it's an estimate, 14,000 cell phone users. All right, Carly. Find f of x equals 44,000. So first of all, is that your input or your output? So is that x or y? Okay, so how am I going to find x then? Which axis? So we go to 44,000 up here, good, and follow it over. And follow it down, and what does that look like to you? 9. Goodness. So that followed that down to 9. So it would be after 9 years, there would be 44,000 cell phone users. So notice I'm using the units. You must use units too if units are given to you. So look at those two problems. What questions do you guys have for me so far? All right. Car ownership. So it's Y is the value in dollars and the years of the ownership. So it's years, comma value. We want to make sure we understand what our X and Y are so that we know how to interpret our solutions. So it's about a car as well. The points are actually given to you on this equation, which is helpful. So Kaylin, it says find f of 1 from the given equation. So our given equation is y equals 1,600 times 0.088, I don't think I said that right, but I'm sorry, to the t power. So is 1 an input or an output? So what will 1 go in for then in your equation? Y or t? T. So t equals 1. So go ahead and take your calculators out, guys, and plug that into your calculators. What? T is an exponent, yes. T is sometimes used instead of x because it usually has to do with time, so t makes sense for time. Yeah. It was written here. Yeah, the equation was written for you guys on the graph. That's where I got it up. I didn't just make it up out of nowhere. So, just so you guys are aware. That was a good question, Sarah. You guys don't want things to magically appear, I'm sure. Iris, what did you get? 14,000 what? Can anybody confirm what Iris got there? Good. So, Iris, tell me what that means in terms of this problem.
In 1 year, the value will be 14,080.
In 1 year, the car's value will be $14,080. Good job. All right, then it says to estimate f of 1 from the graph. So, Olivia, if you were going to estimate it from the graph, we already know that this is t equals 1, right? You'd follow that 1 up. What would you have estimated it from the graph? Before we even knew the equation, what do you think it would have been? $14,000, yeah. I think that makes sense. I think if we were just to have looked at the graphs, would we have said $14,080? No, right? That's kind of a random amount. We would have said $14,080. So, not 80, $14,000. So, when you're estimating from a graph, it's really important that you guys are saying it's about this amount because it's an estimation. So, if we did that, you're right that it's $14,000 from that. So, from the graph, the value of the car after 1 year would be about $14,000. So notice the difference of how we wrote up the first one to the second one. The first one we didn't have to use the word about showing an estimation because we got an exact answer. We plugged it into an equation. That's what equations are good for. Algebra is good for. When you're doing things like an estimation from a graph, it's usually an estimation, so that's why we're using the word about. All right, Madison. Find f of t equals 12,000 from the graph. So, input or output? So that is your y value then. So what's your estimation? Yeah, it's about 2 years. It's not exactly 2 years, right? But you're almost there at 2 years, so about 2 years. So 12,000 is a little more than 2 years if you follow it over a little bit more. Isn't it a little bit more than 2 years? So you can see that there. But so we could say about 2 years, or you could say a little more than 2 years if you wanted to. Now, you cannot use the equation to solve this. You need what is called a logarithm to solve an exponential, and you guys will not learn about that until Algebra 2. So you have to estimate from a graph when you're given the output. When you're given the input, you can do it. But like I said, in Algebra 2, you guys will learn how to solve that. Jenny, what's your question?
Wait, is there car on
Yeah. To start off with. It depends on what car you get. There's cars that sell for, like new cars that will sell for $16,000. Or used ones. If it depends on like what, you know what I mean, if it's been used for a year or two. You don't know what car this is. So, after about 2 years, the car will be $12,000. All right, Kelly, what is the y-intercept, first of all? Tell me what that y-intercept is.
16.
Yeah, and we always write those as ordered pairs so we can really interpret it. So interpret that for me. What does 0, 16,000 mean, Kelly?
After 0 years of the ownership, the value of dollars would be 16,000.
Yeah, so that's basically when you've purchased your car, right? When you purchased your car, it was $16,000. So the initial value, and if you said it the way Kelly said it, I would give it to you too. The initial value of the car is $16,000. All right, look at those 2 slides that you have in front of you and see what questions you have for me. And then go ahead and flip to the next page when you're ready. All right. A fossil is discovered in Utah. The scientists are trying to estimate the age of the fossil using carbon dating. The graph of the data is given below. So we know our ordered pair is years, comma, amount of C14 remaining in percent. So it's a percentage. Whatever C14 is. I'm sure that has to do with carbon, since we're talking about carbon dating. So Hannah, it says estimate what f of x equals 10 is and explain its meaning in context. So f of x equals 10. Is f of x equals 10 the input or the output? Okay, so that means that's your y value. So when you're at 10, what is your x? What are you estimating? About 20,000, right? And again, we have to say about 20,000. So tell me what that means in context. The amount of C14 is 10%. Good. And it makes sense that it's 20,000 years because we're talking about a fossil here. We're not talking about, somebody's age. We're talking about a fossil. Fossils take a while to fossilize, probably. I don't really know. I'm not, one of those people that dig up fossils, although that would be a cool job. All right. Jacqueline says, estimate f of 10,000 and explain its meaning in context. So first of all, is that x or y, input or output, Jacqueline? X, and it's your input. So what is your estimation for 10,000? It's about 30%. It looks like it's almost exactly, but we really can't tell from a graph. So tell me what that means in context. In 10,000 years, the amount of, I guess I should say about in all of these. So let's put about in the first one too. So in about 20,000 years. In 10,000 years, the amount of C14 is about, what percent did you say? 30%? Because it's an estimation, we need to do that. Okay, we're throwing in some average rate of change 2 into this, which is what we've been doing since Friday. So it says, what is the average rate of change over the domain 0 to 10,000? So we need to create our ordered pairs. Alex, what goes with 0? What does it look like?
0.
The ordered pair 0, comma what?
Oh, 10,000.
X is 0. What is Y?
Oh,
100%. There you go. Okay, Alex, let's do this again. When X is 10,000, what do we think Y is?
30%.
We think it's about 30%, right? So it's Y over X, which is the percent over years, because remember, we need to use units if units are given to us. So we do our slope, and you can write this as a decimal since it is a contextual situation. All right, tell me what that means in context. Tell me what that means in context. Who thinks they know what that means in context? Yeah, Jenny? First of all, is it increasing or decreasing?
Increasing, like, as the years go on.
Increasing or decreasing? What did you say?
Increasing.
But it's negative.
Wait, which one are you?
We're on C.
Yeah, that's what I thought.
But it's negative and your exponential is decreasing as well. So you should start as it is decreasing by how much?
0, 0, 0.
And what does that mean? Remember, it's percent over years. So it's, what is that going to be? 0.007
At 0 years. Wait,
percent per year.
is
So-
the 0, 0, 7 years or percent?
Is it on the top or on the bottom? It's on the top, right? So is it the percent or the years?
Percent.
There you go. That's why I write it up this way. Do you guys see why I write it up that way? So that you guys have that idea. So it's 0.007% per what? Year. Very good. Okay, so we need to find the rate of change from 10,000 to 20,000. And then we're going to compare them. It's okay, guys. We will get this. Hopefully by the end of the semester, you guys will be really good at using these units. So we already know 10,000 is about 30. What do we think 20,000 is about? What did we say, 10? So again, it's y over x, which is a percent per year. So it's 10 minus 30 over 20,000 minus 10,000. So that's negative 20 over 10,000. So Jill, what does that mean?
It is decreasing 0.002% per year.
So how do our rates of changes compare then, guys? How do our rates of changes compare? We can't really find a factor because these are estimates for some of them. But what do you notice is happening over time? Is it decreasing by more or decreasing by less over time? It starts decreasing less and less over time, right? It starts off at 0.007, which is bigger than 0.002. So you can just say it decreases less and less over time. And like I said, we can't really determine a factor on this one because these are estimates. And we don't have the equation either. So let's just do one more example, and we'll be done for the day. So we'll do the next one, and then we'll be done for the day. Do we have questions on this one, though? Yeah. No, yours is just putting it in scientific notation. That just means move the decimal place 3 to the left. So the decimal place is here. That's scientific notation. So you move it over 1, 2, 3, and it'd be the same thing. We'll have to look at your calculator later and see if I can get you out of that. Okay. So you don't get confused by that later. Oh, we're still with the fossil. So it's still the fossil. What is the meaning of the y-intercept in context? Katie, what's the y-intercept? Right, say it as an ordered pair. And tell me exactly what that means in context.
That's 0 years and
The fossil has 100% of C14. Very good. So again, we're talking about context. So domain and range is not necessarily going to be negative infinity to infinity, right? So we have to be careful there. So state the appropriate domain. What is the farthest to the left x value we could have? Yes. X value. How many years? So domain is years. What is the least amount of years you can talk about? 0. We can't go negative years, can we? So 0 is our least amount of years. So I'm going to put a bracket on it because 0 is included on our graph, right? 0, 100 is included on our graph. How many years could we technically have? Yeah?
infinity.
You could have infinite years, right? Because we're talking about a fossil here in C14, so it could go on forever tracking. And remember, with exponentials, will we ever reach 0? No, so it's going to be like a really minute percent over time, but it will get there over time, but we never include infinity. So this is because we cannot have negative years. But it could have C14 for infinitely many years. So now let's talk about the range. What is the lowest percentage you could have? What is the lowest percent? Since range is percent, what is the lowest percent you could have? Jenny? 0. And we'll never reach 0, so I use a parenthesis because that means not included. And then Jenny, what's the highest number of percent? 100. We never go past 100. That is included on our graph, so we use a square bracket. So percentages are always between 0 and 100, but we'll never reach 0% because we're doing an exponential, so you're never multiplying by 0. So percents are between 0 and 100. But we'll never reach 0. And that's why that's there. All right, what questions do you guys have for me?